Couchbase provides a consistent approach to data access across all our SDKs. Let's take a look. How does Couchbase expose data? Well, applications access Couchbase services directly via our SDKs, which uniformly offer encryption on the wire, along with JSON document serialization and deserialization, and they stay aligned with the current shape of your cluster by a cluster map. Key value get-set operations or access to map-reduce views happens through direct contact with any node exposing the data service. On the other hand, nickel queries will be passed to a query service node for planning, which will then interact with the index and data services to complete and return that query. Natural language queries are passed to the full-text search service, which manages and replicates its own unique indexing. Eventing works a bit differently in that it relies on our database change protocol to trigger further mutations in response to changes initiated by a SDK. Analytical queries are also initiated by SDK and, like the rest, rely on the data service. These methods are accessible not only directly, but also via the offline-first architectures made possible by Couchbase Mobile. And it's worth remembering that although this illustration depicts all these services on one node, in reality your full cluster would be involved, with various services scaled on appropriate hardware, again all tracked by the SDK cluster map. Couchbase plays nicely with others. We directly support SDKs for virtually every major language, with even more supported by our open source communities. And we directly support connectors for all the major players in the big data ecosystem, including ODBC JDBC drivers. You can learn a lot quickly by scanning the basic profile of our standard APIs. Developers will work with cluster and bucket objects to insert, get, replace, upsert, and remove documents. You can also append or prepend to documents, which is a conceptual entry point to our whole API for SubDocument manipulation. We support optimistic locking via CAS, or check and set values. We also support automatic document expiration, which can be managed by extending the TTL, or time to live, for any given document. We support cluster-wide counters, and queries, whether nickel or FTS, full-text search, are passed how you might expect. Nickel queries can be assembled manually or via a domain-specific language available in our Java SDK. We also support reactive design patterns, including RxJava. As you'd expect, you build your query for either synchronous or asynchronous access, then handle the JSON it returns, in the manner appropriate for whichever language you may be using. Full-text search queries are exposed by a sensible API, with many search types supported for the search strings you passed along. Result faceting, limiting, highlighting, and similar features you'd expect from a full-text search solution are also exposed in sensible ways in the SDK. A further aspect of the unified programming model is that you don't need to access full documents. Documents can be up to 20 megabytes, and depending on the model you design, you may not want to move something that large across the network. The SubDocument API allows you to look up and mutate values at a specified path within a document without getting the whole thing. Or if you prefer a higher level of managed abstraction, you can work with our Data Structures API, creating local map, list, queue, and set objects. You update their local values, and the changes are written back to corresponding subdocuments on the server. Persistence from these data structures is fully managed, and objects are implicitly created on demand. So how might connecting to a bucket and creating a document look like in practice? We'll look at this in Java, but you'll find the same unified approach across all our SDKs. First, you create a connection by pointing to one or more high-availability Bootstrap nodes. After this initial connection, the client will be continuously updated with a map of all nodes and will manage the connections. Then you open your desired bucket. You create a JSON object in some way relevant to your application. You create and assign an ID to that document, then pass it to the bucket. Here, an upsert operation will create the document or update it if it already exists. Then you can get that document by its key and access its values using an approach that's appropriate for whatever language you are using. To learn more, check out our free online language-specific courses. Now, because enterprise code commonly happens in a broader context, we also support major frameworks your development teams may well already have in use, such as Spring, for which we support the Spring Data Couchbase project, or .NET, for which we support the Couchbase.NET Link provider. To keep pace with the rate at which data flows these days, Couchbase explicitly supports reactive programming approaches in our Java and our C# SDKs, which implement best practices in handling large data streams. A fast overview of the reactive design approach is available at reactivemanifesto.org. So does Couchbase have broad open source community support? Well, definitely. We actively and enthusiastically participate in the open source movement. Our server, sync gateway, mobile database, and SDKs are all open source and available. Check out this page for more details and all the links to our open source commitments. So what have we learned? Well, the Couchbase SDK manages your connections, documents, operations, and queries, and is automatically aware of your cluster topology and service distribution. Couchbase supports SDKs for Java, C#.NET, Node.js, PHP, C, Python, and Go, all of which expose a consistent API regardless of language and environment. The SDKs also support SubDocument and data structure APIs. Nickel, as we keep saying, is SQL for JSON and provides overlapping capabilities with some of the document-specific operations. Couchbase enthusiastically supports numerous open source projects, and we support reactive programming approaches in both Java and C#. Now, sometimes things go wrong. Stuff happens. So next up, we're taking a look at how Couchbase handles high availability and disaster recovery. As we say, stick around.